Hi there, and welcome back to another Popetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to continue on with more absolute value graph transformations, where we're going to look at exercise number 2 that says, for each of the following, graph the absolute value functions and describe how all functions are transformed from the parent function. So we're going to start off by, let's take a look at describing how they're transformed. So we know from our shifting rules that two things are being done to this function here. We know that we're subtracting inside 4. So if we're subtracting 4 inside, that's going to shift, undo that and turn on my pen. There we go. We're going to shift 4 units right, because when we subtract inside, that shifts right. And we're adding 2 on the outside of the absolute value. And when we add 2 on the outside, that shifts 2 units in what direction? And if you said up, you're correct. So it shifts 4 units right and shifts 2 units up. There we go. So now graphing that, if we know our vertex is going to be 4 units to the right, 1, 2, 3, 4, and 2 units up, and this thing is not being multiplied by anything, we know our slope is going to be 1. So from in each direction of this vertex, we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and then when we run out of room from that vertex, we're going to go up 1, left 1, up 1, left 1 to make that V-shaped graph. And we could do that for all of the points that fit on a coordinate plane. Once we do that, we could connect these with a nice straight lines to make that V-shaped absolute value graph. And if you didn't go to the edge of your graph, you want to make sure you draw arrows on the ends of those lines. Now looking at part B, we have a different kind of looking one now because we're not adding and subtracting inside and outside. We're doing something inside and then we're multiplying. So in part B, we're adding 1 inside. So this is going to be shifted to the left 1 unit. We're not going to go up or down at all because there's nothing being added or subtracted outside. But also, it's going to do something by multiplying by 3. And we want to remember when we multiply by a number that's greater than 1, that's one of our rules for transformations. When we multiply by a number greater than 1, it's going to make it narrower. So we're going to say, and gets narrower. So again, we know our vertex is 1 unit to the left of 0, 0. So our vertex is going to occur there. And we know our slope is going to be 3, which is the same as 3 over 1. So in each direction off of this vertex, we're going to go up 3, right 1, up 3, right 1, until we run out of room. And then we're going to go up 3, left 1 to make a V-shaped graph, up 3, left 1, until we run out of room. Once we have all the points that fit on the coordinate plane, we're going to take 2 straight lines and connect the points we do have. And since we did not go to the edge of our graph, let's draw arrows on the ends of those lines to show that that graph does indeed go on forever. So this is the absolute value graph of 3 times the absolute value of x plus 1, which is shifted 1 unit left, and it's definitely more narrow or narrower than the parent function. Which brings us to our part C. And in part C, we have 3 things going on. We're adding 5 inside the absolute value. So it's going to shift 5 units to the left. It's also going to shift 4 units down because it's subtracting 4 on the outside. Then we're multiplying by 1/2. So it's also going to get wider because 1/2 is a number between 0 and 1. So this is using 3 of our transformation rules: adding inside, subtracting outside, and multiplying by a number between 0 and 1. So again, we're going to start with our vertex here, and we know our vertex is going to be 5 units to the left of the origin, 1, 2, 3, 4, 5, and 4 units down, 1, 2, 3, 4. And we also know our slope of this is going to be 1/2. So from here, we're going to go up 1 over 2 until we run out of room, which we just did, and then up 1 over 2 in the other direction until we run out of room, which is going to be a little bit longer of a line on this side, but that's okay because we could still see the V-shaped graph. And when we connect these points, it'll really be clear where that V-shaped graph is. There it is. So here we have the V-shaped graph, the vertex right here, 5 units to the left and 4 units down. Also, you can notice that this is definitely wider than the parent function because it looks like it's being stretched right there. So now we have done 3 exercises where we have multiple transformations. We describe the transformations being done and graph them on the grid. If this video was helpful, please give it a thumbs up and go on to exercise number 3 now. Thank you for watching.